So in this video, we're going to dive into understanding the data set that we're going to use to fit our regression models. I've actually chosen the data set Moneyball. Moneyball, they've actually made a movie on this, but it says here in the early 2000s, there were two people that worked for the Oakland Athletics. The Oakland Athletics at the time had financial issues where they didn't have enough money. And so whenever it came time for them to trade players or find better players for their team, they weren't able to pay for the best players. And so the coach at the time, or one of the coaches at the time, was scared that if they didn't make the playoffs, that he might lose his job. And so they had to come up with some sort of solution to this problem. How can the Athletics perform that baseball season and not have to spend all this money on getting better players? Well, one of the guys was doing some analysis on the data for various teams over many years, and noticed that there was a really high correlation between the on-base percentage and the slugging percentage of a team and the number of runs scored. And I reckon the hypothesis was that if the team could score more runs, then they would win more games and be more likely to show up in the playoffs and get to the playoffs. Well, the data showed this. They actually wind up getting being able to pay for some players that, although weren't as pricey because they weren't as popular, they had a knack for getting on base, and they had a knack for scoring runs, and they actually did well, and they got into the playoffs that year. So let's hop over to our data set. So I've actually loaded this in. I've saved it as a CSV file. You'll be provided with it if you're taking this course. And I'm looking at it here, and it's got the team name, the league they're in, the year, and then how many runs this team scored that year, runs allowed that year, how many games they won, their on-base percentage as a team, their slugging percentage as a team, their batting average as a team, whether they made the playoffs or not, and how many games they played. Here is the opposing team's on-base percentage for that year and the opposing team's slugging percentage. And these are for all the years. This is data for every team across all these years, spanning from 1962 to 2012. But most of the years between 1962 and 2012 are covered in this data set. There's 1,232 rows and 15 features. And what we're actually going to change up, because I don't want to do just what Moneyball did, because that's a little bit too simple and it's already been done. What I really want to do is I want to see which features are the best predictors of the percentage of games won. So we're going to create this feature called win rate, and it's the percentage of the games that season that a particular team won. And then we're going to create two features. We're going to create slugging difference and on-base percentage difference. So slugging difference is going to be the difference between that team's slugging percentage that season, like for example right here with Arizona, difference between that team's slugging percentage and their opponent's slugging percentage. And so if this number is higher, that means that the team had a better slugging percentage than their opponents that year. And the same thing goes for on-base percentage. And then what we're going to do is we're going to select just these features from the data set. And I'm keeping the regular on-base percentage and slugging percentage, the batting average and runs scored, and then the new ones that I created along with the win rate. And so I'm going to run this cell. Oh, sorry. I have to reload in the data set because I ran this before. Here we go. Nice. And so first off, what is slugging percentage and what is on-base percentage? And so on-base percentage is what it sounds like. It's if you're familiar with baseball, it's the percentage of times that a player is on base. And so whenever they don't strike out or get out, they're actually on base. And so we want to know, of the number of times they actually get up to bat, what percentage of those times are they on base? They actually get on base. The slugging percentage is going to be how many bases, when they did get on base, how many bases did they touch? How many bases did they get? And so the slugging percentage goes further and says we don't want to just track, whether they got on base. We want to track how many bases they actually got whenever they did hit. And so if you're familiar with baseball, that makes sense. If you're not, please look it up. It's a very popular sport. And so here's our data set. And what I'm going to do first, before I go into exploring this data set, because you always want to explore your data set before you train your model to see like what the relationships are. So we're going to split this data into a train and test set. So why do we split into a train and test set? So in machine learning, what is commonly done is you train your model on what's called the train set, and then you hold out a portion of it to test the model. And this is to make sure that your model, is more generalizable, so that you can have more trust in it whenever you go to put it into production. That on new unseen data, it'll make accurate predictions. And so that's why you split it up. You hold out a piece of the data set and you train it on this just to see how it generalizes to unseen data so that you can have more trust in it whenever you deploy it. And so why are we splitting right now? So we try to split before we do exploratory data analysis and start analyzing the relationships between different features, because we don't want any observations or data from our test set to leak into our training set. What we don't want is we don't want to sit here and look at all the relationships between the different features on the entire data set and then go down to choosing our model and choosing the features we're going to use to predict what. We're not going to do that, because then we've used test data to inform our modeling approach for the train set, and that's a form of data leakage, and we don't like data leakage. So I'm going to split into train and test. I'm going to randomly select 80% of it as a training set and then randomly select the other 20 as a test set. And that is how it's commonly done. You can use other percentages, but 80-20 is pretty common. So here's the link to the data set. Here's all the features that were in the data set. And I'm going to plot right here. This is probably the quickest way to see relationships between your data. I'm going to use Seaborn's pair plot function right here on the train data set, and I'm going to just plot different scatter plots between each of the features in our data set. And this may take a second because it's got to generate a lot of scatter plots. But here you go. So let's start with the original hypothesis, the original one that the two members of the Oakland Athletics had. They said that runs scored can be predicted. They were saying that on-base percentage and slugging percentage for a team led to more runs scored. And so it's the on-base percentage. You can read this as these are these first two columns. This is on-base percentage and slugging percentage on the x-axis. If you go up to runs scored right here, you can see that on-base percentage and slugging percentage are highly correlated with runs scored. So is batting average. This is batting average right here. And this would be batting average on this axis and runs scored on this axis, and they're highly correlated. But we're not interested in runs scored, we're interested in the win rate. And so the percentage of games that team won that year out of all the games that they played. And you can see that on-base percentage, slugging percentage, and batting average, and even runs scored, they're not really as linearly related to win rate. There's a lot of variance here. This is a very wide set of points. But if you go down to on-base percentage difference and slugging percentage difference, on-base percentage difference, in my opinion, it actually does look a lot more linearly related to win rate. Slugging difference does too. And remember, these features are just the difference, so between these two metrics and their opponents. So it's really not so much how often a team got on base, right? What's really the difference is how much they get on base relative to their opponents and how that relates to the percentage of games they won that year. And so that's the hypothesis that I'm making, is that there is this linear relationship, and we're going to fit a simple linear regression model and a multiple linear regression model to this data to predict the percentage of games that a team will win in a particular season based on base percentage difference and another feature that we'll get to later. But that's the exploratory data analysis. We're going to head into fitting our model next.